Okay, go ahead and get out your notes from last week, 1.7 Composition of Functions. We are going to pick up where we left off. So go ahead and scroll down here all the way to this table. I'm going to use two different colors to represent each table. So on the left we have the function g of x, and here's some ordered pairs represented by that function in a table. And then on the right side I have h of x, and here's some table values for that function. So we're going to use these tables in order to find these composition of functions. So let's start with A. I'm going to look at g of 1 first. So remember, you start always with the one most inward in the parentheses. So g of 1 means I'm inputting a 1 into my g equation, and I would get an output of positive 2. But I can't stop there. I need to take that and plug it into the h equation. So I'm going to go to when my x equals 2 on the h equation, and that would give me positive 10. So h of 2 would equal positive 10. Okay, now let's do another one. H of g times 2. So g of 2 means I would plug in a 2 onto my g equation, which would equal negative 1. But then I need to take that and plug it into my h equation. And when I plug in a negative 1 into my h equation, I get an output of an 8. Okay, number C, or letter C. We're going to start with G4. So I'm going to plug 4 into the G equation, and that would give me a negative 5. Okay, now we're going to see if we can plug negative 5 into the H equation. But look, there's no negative 5s there. So this one's actually going to be undefined because there's not a negative 5 in that table for me to input. Okay, it's kind of like with that seating chart. If I said like, find the person behind the last row, there was nobody behind the last row. So it would be undefined. Moving on to D, notice that the order has switched. Now it's g of h of negative 3. So this time we need to start with the h equation. I'm going to input a negative 3 into the h equation, which would spit out a positive 4. I'm going to take the positive 4 and plug it into the g equation. So right here again, when I input a 4 into the g equation, I would get out a negative 5. Okay, let's look at an example of a graph now. Once again, I'm going to go ahead and circle them just so you can kind of get a visual of where I'm at. The f of x equation is in purple and the g of x is in green. So on letter A, we're going to find g of f of negative 3. So I'm going to start with the f equation since it's the closest to the input negative 3. So I'm going to go to my graph of f of x and input a negative 3 in, which remember is my x value. So I'm going to go to when my x is at negative 3, which is right here, and then look at what my y value is, and that would be positive 1. Because remember, this point would be like at negative 3, 1. But I can't stop there. I have to take that answer and plug it into the g equation. So I would input g of 1 into that g of x graph. So go to when your x equals 1, and you can see that the y would equal negative 1. Alright, moving on. This time we're starting with the g equation. So I'm going to plug in g equals 0 into that graph. It should be right here. And I can see that my y value is positive 2. Then I need to take that 2 and plug it into the f equation, or to the f graph. So if I input a 2 into it, that's when my x equals 2. I can see that my y would also equal positive 2, because this point is at 2, 2. Alright, last but not least, we're going to go over some of these review problems down here. So if I want to find g of 3, I'm just going to input a 3 into the g equation. Let me erase some of this off so we can see a little bit better. So I'm going to input a 3 into the g equation, which is the one in green. So if I go to when my x equals 3, I would be right here, which means that the y would equal positive 1. So g of 3, whoops, there we go, equals positive 1. Because that's at the coordinate 3, 1. Okay, number 2, find f of negative 2. So I'm going to go to the f equation and plug in a negative 2. So whenever my x is negative 2, I would be right here, which would tell me my y would be at negative 1. Moving on to number 3, now we need to find the inverse. So remember, the inverse is whenever you switch your x and your y's. So instead of actually looking at when your x equals 3, we're looking at when your y equals 3. So go back to the g equation, and we're going to look at when our y is 3, which would be up here at the very top. So when my y equals 3, my x equals negative 1. So the inverse of g3 would equal negative 1. Now, last one, the inverse of f at negative 3. So remember, we're not looking at when x is negative 3, we're looking at when y is negative 3, because it's the inverse. So whenever my y equals negative 3, would be right at the bottom. And I can see that my x value is at negative 1. So the inverse of f of negative 3, whoops, that's supposed to be an f.